All right, so I figured I'd make quick little recap videos of each of the sections that we've tackled in the last 2 weeks. So the first would be the second half of last week when we got into part 4, probability. One of the biggest things I always tell my students for that probability section, especially my students in my X class, which is that supported class, for the students who don't necessarily have the math skills required to be in a transfer level math course, is that there's 4 types of probabilities, right? Our probability of just one event by itself, our joint probabilities of the intersection of 2 events, and we have our OR probabilities and our given probabilities. And one of the hints I always tell students about part 4 and about finding these probabilities is to pay attention to the idea that almost all of our different problems can be solved with the use of the display, whether it's a tree or a table. And if you have a table, which you can make from a tree or from a Venn diagram, right? These are on the table. So when you're doing that probability displays worksheet, there's no reason to do any calculations to get these values. In fact, it's one of the things that drives me a little bit crazy looking through the answers that you'll find online for that worksheet, because people have posted my worksheet online, is that they will do a lot of calculations to find these 2 values when really you should just be flipping the page over and grabbing them off the table. On the other hand, the OR and the given, these both require the use of a formula. The formula, of course, all the different pieces of it can be found on the table, but you need to use the formula to find these 2 probabilities. The other piece that I always like to really hammer home for students is the idea that this conditional probability is probably the most important one that we'll cover. It's at the heart of what a p-value is. A p-value is a conditional probability, and that's where we're headed next week or maybe the week after. Anyway, the point being that this is going to be tested multiple times, and what you're looking out for is whenever I mention both events and there is no keyword that would mean and or, that's when you want to look out for our if, of, given, anything that's telling you that we know we're dealing with one particular group or one particular event that's already happened. And whatever comes after this in your sentence is what's going to go behind the line in that notation. Because if you have this notation backwards, which is a very common mistake, it's a really easy way to get your answer wrong. All right, so a couple of other notes about those 2 different displays. Our tree diagram. In a tree diagram question, the only way that you're going to be able to make a tree diagram is if you have 2 of those conditional probabilities for those 2 secondary branchings, and then 1 probability by itself to begin with for that first split. So that's a tree. One good thing I will say is I've had students on that struggle bus discussion board for next week show there's a good, I think it's Khan Academy, but maybe it's elsewhere, a lot of AP Stats classes, what they'll do is they'll use a hypothetical 1,000 when they're working with the tree diagram. And that can make a little more sense as to what's happening and how we're just splitting up these 1,000 people by these different potential ways to describe them, right? So if you're looking for the tree diagram's not making sense, that might be a good place to go. Hopefully someone will post that as their answer in the struggle bus, because the tree is usually where students have the most trouble. After you have the tree, like those will be your given pieces, which will fill in the whole tree, right? If you haven't seen that, you need to go back and watch videos. My favorite questions are always asking for the opposite thing that you had. So if we split by A, I'm going to be asking you to find me B. And if our conditionals, which will always have the A and the A complement behind, the other question I will always ask you is for the opposite conditional. So just a heads up that if you ever get a value out when you're doing additional calculation problems after your tree that was in your tree diagram, you probably mixed up that direction. It's an easy kind of way to check and say like, oh, this should be the opposite of one of those things that's already in my tree, and if it's not, I've made a mistake. And then the table, I don't have a whole lot to say about the table and the Venn diagram besides that, you know, you're going to see that on the test. You're going to, so make sure that you know how to fill one in and then how to find probabilities from it for both of those. The Venn diagram, I've seen some issues with creating it. When we have our table, you want to make sure our two events that intersect are on the opposite rows and columns. It doesn't matter which one you put where, and that you put your complements next to them. And then you have a total row and a total column. And then when you go to your Venn diagrams, and students have been having trouble about how to set that up, you want to make sure that you have your two circles labeled again with those two events that we want to intersect. Because if this circle represents A, that means I've already got A complement here. It's everything not in that circle. And so you don't need an A complement circle because it is already there by not being the A circle. And then last thing I'll say here about this Venn diagram is these four numbers here are the ones that should go into your Venn diagram, because your Venn diagram is only showing intersections. A very common mistake is students want to put, if our probability of A was 0.42, that's a terrible looking 2, but if it was 0.42, they really want to put 0.42 right here, when this particular section is only this little piece of A. If we add both pieces of A together, that's when we should get the 0.42. So that's just a little baby recap of the things that are in part 4 and sort of the most important pieces, in my opinion, moving into the exam and, you know, looking back at that probability displays worksheet.